Have you heard of Apophis? Apophis, the bringer of God knows what sort of death and destruction in years to come. It was a character on Stargate SG-1 once upon a time. Well, Bennu isn't quite Apophis. Bennu is smaller and even the name sounds nicer, and NASA has managed to extract samples from Bennu and bring them back to Earth. The purpose of which is what, Seanie Morris?
We want to have a look at the very early primordial origins of the solar system. So this was kind of a first for NASA, but not the first time that a sample from an asteroid has successfully been returned to Earth. Japan has done it twice, back in 2010 and 2018. So this time NASA was trying it out. And Bennu, when it was discovered in 1999, it was shown that it is quite close to Earth. It crosses our path now and again. It's a potentially hazardous object in the future. But it also showed that its surface reflectivity was very dark. So that meant that it was highly undisturbed. Most asteroids would have a bright surface because as they would come close to the sun, the heat would, fracture it and gas would escape and things like that. Whereas Bennu looked like it was very dark. It's what's called a carbonaceous asteroid. So it's somewhat very, very well preserved, despite having floated around for 4.6 odd billion years. And that's why it was the target for this mission.
So talk to us about the logistics of getting there and extracting the material and getting it back all in one piece.
All in one piece. It's a very time-consuming venture. It all started in September 2016 when Bennu was launched. Up to that point, excluding the launch costs, it was nearly an $800 million endeavour by NASA, but it spanned many years of development and a couple of different nations as well. So having left Earth in 2016, it took an almost 2-year trip to reach Bennu.
What distance?
I don't know the exact distance at that time. Its cumulative distance is about 6.2 billion kilometres.
Wow.
Over these years, 7 years. So by the time it got there after a 2-year gentle flyby through space, it put itself in orbit around Bennu. At this stage, it wasn't going to land at all. It didn't know where it was going to land, so it spent 2 years photographing the surface. And by doing that and sending these spectacular images, I mean, I was looking at some of these video and photo footage from the lander. It's like you're walking in. Have you ever been to the Burren? The stoniest part of the Burren. That's what the surface of Bennu looks like. Just no life, nothing, and it's just sheer fragmented rock. And it picked 4 landing sites that were given names of birds. There was nightingale, osprey, kingfisher, and sandpiper. And during those 4 landing sites to be determined, Queen guitarist Brian May was actually on the team to help them identify which of the 4 would be the best, and Nightingale won. So then in October 20, that's when it went to do a soft landing. Now, not necessarily soft. The idea was that it would come down gradually, and then with those couple of meters left, it would almost pound onto the surface. And by raising the dust and fragments of sand, maybe bits of rock, because Bennu's gravity is so slight, that whatever was floating up would get caught in its container. And they're hoping from anything from a teaspoon or 2 to maybe 2 kilograms. They didn't know what it was going to be. And then there was also the risk of, would that debris hamper closing the capsule? So all this, from a huge distance of hundreds of millions of kilometers away relative to Earth at that time, after 4 years in space, and you're hoping, is this going to work, And it did. So it put everything in, but didn't take off just yet. Had to wait till it got a little bit closer to Earth because they knew where Bennu was going to be relative to Earth in order to lift off and do a nice, slight sail back. That's exactly what it did. So as it got close to us a couple of days ago, it detached the return capsule, nicely, tightly wrapped, and they knew where they wanted it to land, which was the Utah Missile Testing Range. And it came through the atmosphere, the parachutes deployed, and it literally landed 6.2 billion kilometers later, 3 minutes early, on X marks the spot in the Utah desert.
Like clockwork.
Like clockwork.
Why do all of this?
It is, as Bennu is such a well-preserved specimen of the early formation of the solar system. Now, it had been theorized back in the 60s and 70s, and somewhat proven since, that the potential building blocks for life are out there in space. Earth was not born with them. It was the early bombardment period in Earth's history to which comets, which were all over the inner solar system, were bombarding us. And then when you mix it with water and volcanic activity, electricity from lightning, rich atmosphere, gases such as methane and carbon and so on, that's how it's believed life was brought to Earth on an evolutionary level. Bennu could potentially have those materials locked in its samples because it was so undisturbed. It's such a dark body that we now have those pristine materials that we can kind of unlock a few more secrets of what these early asteroids were like. Like when you go further out, well beyond the orbit of Pluto, you've got the Oort cloud, which is full of asteroids. The odd one gets bumped in our direction. And if it has very, very little ice or nearly no ice at all, by the time it comes close to the sun, it's still being well preserved because there's no breeze, there's no heat, there's no cold in the classic sense of an atmosphere to erode or upset anything. So we have this pristine sample that is now going to be analysed through a few different centres around the world. Canada is getting a few grams. Japan will get a few grams. There's a few European nations who will get a few grams as well, but predominantly through the United States and NASA's partners, they have these materials to have a look. The total amount that was brought back, I think, was just over or just under 250 grams. It's enough to work with. And we hope that we're going to find some of those secrets unlocked.
Not bad from a little dust cloud.
Not bad at all.
When are we going after the big boy, Apophis?
It's on its way now. So OSIRIS REx, as it was till Sunday, is now OSIRIS-APEx, AP for Apophis. And the intent there is more of an observatory mission. It doesn't have another collector. But Apophis is something that's going to kind of grab the attention in 2029 because it's going to come by Earth very, very close. It's potentially going to be seen by the naked eye. That's how close it was. When it was first discovered, and I think you and I talked about this many years ago, initially it was thought it was going to be a potential planet killer because the pass in 2036 looked like it was going to rendezvous literally with Earth. But as the passes and the motions of everything go around and you get your supercomputers to plot everything, while it will show it's going to pass very close to Earth in 2029, they've ruled out a collision in 2036. So it's by continually observing it. And we have to see, once it passes by Earth. The computers are good, but, physics will rule everything down to perfection. How much influence will Earth actually have when it passes? But they have essentially ruled out that Apophis is going to annihilate us. Although Bennu itself was a potential Earth killer. I think in 2148, that's why it's a potentially hazardous asteroid, PHA.
Well, you and I won't be around to worry too much about Bennu.
No, we won't.
Finally, for listeners who are of a more utilitarian or capitalist mindset, is there any potential to start mining these and bringing back minerals and valuables?
Bennu itself is a very small asteroid. It's only about 0.5 kilometre on either axis. An asteroid is not perfectly circular. They're often irregular in shape. So it's short. Its minor axis is only 508 metres long. Its longest is 580 metres long. So it wouldn't it's boulder. It's a giant boulder. But larger asteroids would have accumulated more minerals from those formationary periods 4.6 plus billion years ago. And that's why an awful lot of the solar system, the rocky materials like Earth and the other rocky planets have an awful lot of iron and nickel. And there's the potential there, plus other metals like gold, platinum. Diamond, not so much. There was someone that asked me before whether there be, gemstones. Not in the classic sense because they need an awful lot of volcanic processes to create those. But in the formation of our solar system, which came from the death of a star before us that went supernova. In a supernova is when you're able to produce those heavier metals from iron and above on the periodic table. So Bennu itself is not necessarily a mining candidate, but there are other mining candidates out there that some nations on Earth are considering about going out there, and the privatization of such ventures in space.
Yes, watch the corporations, watch Elon and friends.
Yeah.
Seanie, if you want to know more about Midlands astronomy, where do you go?
Fortunately, come on down to the Athlone Sub-Aqua Club tonight. We got our first September lecture tonight. Otherwise, join us up on Facebook.
Seanie Morris, thank you very much for your time.
Thank you, Will.
Average temperature at the moment, 15 degrees.